Hi everyone, myself Dinesh. I am working as assistant professor in the Department of Mechanical Engineering from SNS College of Technology. Okay, so in our previous video, we have seen the definition of FMS and also followed by why FMS matters in today's world, and also we have seen two applications of major applications of FMS. Okay, so this is a part 2 video of FMS. So here we are going to see the overall mind map. Okay, when it's come to mind map, it's the FMS or article structure. Okay, the structure view of FMS. So as you seen in this picture, so the FMS can be mainly classified into four types. Okay, so in the definition also we have seen that FMS is an integration of four things. Okay, that's what explained in this picture also. So the first, it consists of workstation. Okay, so workstation is a place where it performs precision and machining operations. Okay, so the first part is CNC workstation. That's the place where machining operation is taken place. Okay, so it follows by the storage system. Okay, in the storage system, the parts are stored. Okay, for example, we can call any warehouse as a storage system. And then the third one is material handling. So as we seen in our first video, so material handling is transferring material from one place to another. That's what material handling is. For example, we can use conveyors or automated conveyors or AGVs or robot moving parts. Okay, so robot can also use in moving parts from one place to another. Okay, so the third one is material handling, and the final one is computer control. Okay, so this is where the overall data is flowed and scheduled for the entire process. Okay, so these are the four main components of FMS: CNC workstation, storage system, material handling, and computer control. Okay, so an FMS integrates five critical subsystems that work together seamlessly. Okay, so CNC workstation perform the manufacturing operation, right? So we know that the CNC workstation is the place where machining operation is done, while automated material handling moves part from one place to another. That's what the material handling does. And then storage system buffer materials and finished goods. Okay, the storage system we saw as a warehouse is the place where the goods are finished goods are stored, and the computer control system coordinates all activities, and human operation monitors and optimizes the entire process. Okay, so the entire process is monitored by human operators. Okay, so this is the mind map, or we can call it as a system view of a flexible manufacturing system. So when it's come to DT process, we have to understand the design thinking, understanding the problem. Okay, so when it's come to FMS, we have to understand the problem first in order to understand why we are using this. Okay, so the main thing is frequently setup changes and low flexibility and high downtime. Okay, so frequently setup changes. Okay, so that we all know that the traditional system requires hours of manual reconfiguration between different product run, leading to significant production delay. Okay, so we are for example, we are producing an part which we alter any design in that part. The manual traditional system, we have to it will take more time to make that process come into account. So but when it comes to flexible manufacturing system, those changes can be easily fixed in the by the means of our FMS layout. Okay, that's what called frequently setup change. And then low flexibility. Okay, so the changes can be done at any cost at maximum speed. And for example, if you take a real world challenge, uh, jobs of manufacturing producing custom hydraulic valve struggle when handling 15 plus product varies per month, spending up to 40% of their time on setup activities rather than actual production. Okay, so this is a real world challenge. So